On the back here. Yesterday we were solving radical equations. Our job was to get the radical by itself, right? And then if it was a square root, we squared it. If it was a cube root, we cubed it. Okay. So the top and the back side, we don't have radicals anymore. We have exponents. Okay. With these rational exponents, realize these rational exponents could be written as radicals, couldn't they? Now, your first job is still the same. I'm going to leave them with rational exponents. I'm not going to go the radical route. I think that gets too confusing. Okay? But your first job is still to isolate the radical, except my radical is going to be isolating whatever my rational exponent is on. So in this case, what's already on the left side here, x squared plus 5x plus 5 to the 5 halves, I want that isolated. Now, we want to get rid of the 5 halves power. So we're going to raise it to another power. What can you multiply 5 halves by that will get it to cancel out essentially? Five halves can multiply by 2 over 5. And remember, we reviewed exponent rules last week before, right? When you raise a power to a power, you are multiplying the powers. Now, if we raise the left side of this equation to the power of 2/5, guess what? We're raising the right side of this equation to the power of 2/5. Okay? Well, side note over here, guess what 5 halves times 2/5 is? It's 1. So they cancel each other out. 5 and 5, 2 and 2. That is just 1. And so we have x squared plus 5x plus 5 raised to the power of 1. Or in other words, x squared plus 5x plus 5. So your job is always going to be to, when you see a power, a fraction power, raise it to the reciprocal. Now, on the right, 1 to the 2/5. Now, I'll be honest, what's 1 to any power going to be? 1. So that's an easy one. But in any other case, what I would suggest is put 1 under the radical. What's 2/5 tell me? The 5 is it's the root. It's 5th root of 1 to the 2nd power. Well, what's 1 to any power? 1. What's any root of 1? 1. So we essentially have the equation x squared plus 5x plus 5 equals 1. Okay. Use what you know. How are you thinking we're going to solve this?
5.
Not 5. Go the other way. Subtract the 1. Because we want to make our equation equal to 0. So we're going to subtract 1. And our goal to make the equation equal to 0. So now I'm going to have x squared plus 5x plus 4 equals 0. After you get a quadratic equal to 0, what do we want to do? Factor. We did this yesterday, didn't we? Okay. We did this parts of this yesterday. So we're factoring into 2 parentheses. X squared is going to break into x and x. What do I need my numbers to multiply to be? 4 and add to be 5. What's going to multiply to be 4, add to be 5? 4 and 1. X plus 4, x plus 1. Am I done? Are those my answers?
Yeah.
No? Wait, before we check, I don't want to even check yet. I want to set each part equal to 0 and get our actual solution. So if it's x plus 4, subtract 4 and get negative 4. If it's x plus 1, subtract 1 and get negative 1. Okay. Now, guess what? just like yesterday, you've got to check them. Maybe both answers work. Maybe one answer works. Maybe neither answer works. We've got to check them. Okay? Now, calculator can be helpful here. It's up to you. But as I do my check, if I put in -4, -4 squared plus 5 times -4 plus 5, all of that to the 5 halves, I need to see if that equals 1. Okay? Yes?
Oh, wait, I was going to say that. Never mind. You got it.
Okay. Well, does it equal 1?
No.
No? You sure?
Wait, does it?
I don't know. Let me see. -4 squared is
I didn't check 4.
16. Oh, I'm checking -4 right now.
I only checked 1.
Okay. -4 squared is 16. 5 times -4 is -20 plus 5. So 16 minus 20 is -4. -4 plus 5 is 1. What is 1 to the 5 halves going to be? 1. 1 to any power is 1. Does 1 equal 1?
Yeah.
Yes. So, does -4 work?
Yes.
Yep.
It does. Did you try and shortcut and just check one and assume the other one won't work?
Yep.
Okay. I believe I warned against that yesterday, didn't I?
Yep.
Okay.
Oh.
Okay, now we're going to check -1 because we're not going to assume the other one doesn't work. So, -1 squared plus 5 times -1 plus 5, all raised to the 5 halves. I want to know if that equals 1. -1 squared is 1 minus 5 plus 5. Well, 1 minus 5 plus 5 is going to be 1. And you have 1 to the 5 halves power. What do you know?
Oh.
1 equals 1. So, in this case, it doesn't always happen, but it can. Both pieces work. Okay? So be aware. I know it's so easy. I'm guilty too. Oh, this one works? Oh, this one probably doesn't work.
Yep.
Yeah, no. Don't do it. Okay, questions here. Do we follow some of the basics?
Yep.
Okay. Now, how are we feeling? Do we need to do both of these or one of these?
We should do.
One of them. I think they're basically the same.
I think we should
Well-
be.
Well, here's the thing. If I do anything, I'd actually prefer to do C.
But no.
I know, but there's different issues. But I think there's one in homework more like C, if I recall. So, okay. Well, we need to talk about B, though, for a couple other reasons I'm realizing. So, let's talk about B.
Yeah.
Now, the big deal is the rational exponents, right? Get your rational, the fraction exponents by itself. Do we have that? Yeah, we have x plus 18 to the 3 halves. Now, this guy over here happens to have an exponent, but it's not a fraction, so it's not as big of a deal. How do you get rid of an exponent of 3 over 2?
Well. Times it by 3 by 2. No, 2 over 2.
2 over 3. Now, what I do to the left, I do to the right. So I'm raising both sides to the power of 2/3. Realize on the left, 3 over 2 times 2 over 3 is going to cancel and be 1, so I just have x plus 18. Okay? And that was because 3 over 2 times 2 over 3 is going to be 1. Now, what about 3 times 2 over 3? 3 is a fraction, is 3 over 1. What happens here? 3 times 2 is 6, divided by 3 is 2. Or I say cancel the 3's and I just get 2. So on the right, I actually end up with x minus 2 to the second after I multiply those. Okay? And now it's a matter of how do I solve? X plus 18 equals x minus 2 quantity squared. Thoughts?
Times the right side by 2. By 2 squared.
Okay.
Yeah.
So right side, various people are saying different things, all leading me to this same piece. X minus 2 squared means I have to multiply x minus 2 times x minus 2. So distribute, and you're going to have x squared minus 2x minus 2x and plus 4. The left is just a plain old x plus 18 that I'm going to carry down. Okay? If I clean up the right, I have x squared minus 4x plus 4. Thoughts on what to do next? Need to take this equation and make it what?
Equal to 0.
Equal to 0. Everyone came alive at once here. So in order to make it equal to 0, I'm going to subtract x and subtract 18, keeping my x squared term positive. So 0 equals x squared minus 4x minus 1x is going to be minus 5x. 4 minus 18 minus 14. And we need to factor.
Yep.
I got you.
Yep.
Right here. All right.
X squared is x and x. What about my numbers?
Minus 7 plus 2.
Okay, multiplying to be negative 14, adding to be negative 5. So negative 7, positive 2 will do the job. Set each part equal to 0. And we get solutions of add the 7, you get 7. Subtract the 2, you get negative 2.
But
One
you're
of them
not
doesn't
done. I learned my lesson.
Okay. Landon's claiming a learned lesson here.
Yep.
Don't assume they both work.
But I don't know how to do it.
Oh, I do.
Okay.
Well, I don't because the
I understand.
So go back into the original. I'm trying to decide where I want to put this.
I have a question.
Yes.
Okay, so I start from the, like, x to the second minus 5x minus 14 equals 0. Can you do that? Because it works.
You're wrong.
But it works.
You got both answers worked here, didn't you?
No.
Both answers would work right there.
I got negative 2 doesn't.
I would guess you made a mistake there because at this point, both answers work.
I don't think so.
So are you making sure when you square the negative to put it in parentheses on your calculator?
Can we do it?
Okay, now.
Let's test around. Let's see if we get the same. We got the same answer.
Well, and I agree. I do have a non-working answer here. But I also know if I put negative 2 in right here, I'm going to get 4 plus 10 is 14 minus 14 is 0. And so at this point, negative 2 works. But up in the original problem, it's not going to.
4 minus 10 minus 14 is negative 2.
Okay, let me put my 7 in here. So 7 plus 8 to the 3 halves equals 7 minus 2 to the third. What is 7 plus 8?
18.
15?
Yeah.
Ah, there we go. There's the, okay. Back it up, back it up. Nope. I was trying to, like, why are we saying, what are we talking about 18? I don't understand. Okay, 7 plus 18, better,
Yes.
is 25. 25 to the 3/2 is the square root of 25 raised to the third. What's the square root of 25?
5.
5. What's 5 to the third?
125.
125. Now go back up on the other side. 7 minus 2 is 5. 5 to the third is 125.
Oh, it does.
So what do I know? 7 works. Okay? Now, go back in, put negative 2 into the original. Negative 2 plus 18 to the 3/2 equaling negative 2 minus 2 to the third. Negative 2 plus 18 is 16. When we say 16 to the 3/2, that's going to be, 2 tells me to say the square root of 16 raised to the third. The square root of 16 is 4. Not half of 16. Guys, focus, please. Square root of 16 is 4. 4 to the third is 64. Negative 2 minus 2. Negative 4. Negative 4 to the third, negative 64. So this does not work in the original problem.
I got the same.
By luck.
Like, ended on this side too.
You're making a mistake, man.
I don't really think I am. Because that's 4, and that's negative 10, minus 14 is negative 20.
That's smarter than that.
You're putting a negative 2 right here, so that's going to be plus 10.
Oh, okay, gotcha.
So we put in the negative here, but negative times negative makes it positive. So I think that's why you probably scribbled that out. And then you didn't put negative there. Or maybe you just accidentally put it in positive.
Yeah, because these are strokes.
Yeah. Okay. Oh, okay. So yeah, you're putting in negative 2.
Okay.
That's the difference. Okay. Okay.
Doing theater now.
Well, I think what I'm going to say about C, because I want to get down to the bottom part, is I'm going to show the first step. In that, before you can raise this to any powers, what must I do on part C? You have to move that 14, yes? If it's a minus 14, we're going to add that 14. And so when we do that, we end up with x squared minus 3x minus 6 to the 3/2 equaling 8. That is the point you would raise it to a power. Okay? What power would you be raising it to? The reciprocal of 3/2 is 2/3. And I'm not going to go any farther with it because I want to make sure I get through the next 2 examples, make sure we have examples of those because there are some tricks there. But you would keep going from here. Man, there's good pieces there. No, I looked at the wrong one. Okay. You get answers here if you continue this on your own later of 5 and negative 2, and they both work. Okay? Now, I want to move down to the bottom section. When you look at the next section, what's different here? They have,
Word scrap.
nope, I'm not to words yet.
Square roots.
How many square roots?
2.
2. Have we had other problems with 2 square roots yet? No. Okay. We've just had 1 square root where we say get the 1 square root by itself and square both sides. Now, what I'm going to say on this next section, there are 2 radicals. Your job here is to separate the radicals. You want 1 radical by itself, and the other radical is just going to move and be with whatever else you have. So my job here is going to be, I was going to write it right here, and I've got the recording thing in the way, is we are going to separate the radicals when you have more than 1. Okay, so we're going to separate radicals. And then it's still going to be the same thing that we're going to square both sides. So, as I look at example A here, I have two radicals, yes? They're on the same side of the equation, which I don't want. I want to get them on opposite sides of the equation. Which one's going to be easier to move? Probably the square root of 2x, yes? How do we move a minus square root of 2x? Plus it, right? The opposite of subtracting square root of 2x, we're going to add. So I'm going to add square root of 2x over to the other side. What remains on the left? Square root of x plus 9. On the right, 3 plus square root of 2x is 3 plus square root of 2x. Once you have your radicals on opposite sides, my job is to square them. Well, not square them, square both sides of the equation. So if I square the left, then I'm going to square the right. Now on the left, what happens when you square the square root of x plus 9? You get x plus 9, yes? Same old, same old. Now the catch is on the right. What happens when you square 3 plus square root of 2x? Not exactly. We need to
Oh, wait, you guys split up. Alright.
okay. Similar to a trick from yesterday, we have to FOIL this out. If you just say, I agree that 9 is going to be part of my answer. I agree that 2x is going to be part of my answer. But you're missing the middles. Okay? So, I've got my x plus 9 on the left. On the right, I'm FOILing. 3 times 3 is 9. 3 times the square root of 2x is 3 square root of 2x. Insides. 3 times the square root of 2x is another 3 square root of 2x. And square root of 2x times square root of 2x is going to be square root of 4x squared, or 2x. Right? Remember how we've talked about when you multiply a square root by itself? You could just go ahead and say 2x. Now, clean up that right side. So I still have the x plus 9 on the left. On the right, I have a 9. What's 3 square root of 2x plus 3 square root of 2x? 3 plus 3 is going to make it 6 square root of 2x. Plus I still have a 2x. Okay, guys. What do we still have hanging out in this problem? We still have a radical, don't we? Okay. So we're in a better position. We had 2 radicals. Now we just have 1. So we're going to reuse our technique from yesterday. We have 1 radical. How do we get rid of that radical? Isolate it and then square both sides. So we're going to square both sides one more time, but not until we get the radical by itself. What do I need to move away from the radical term? The 9. How do I move this 9? If it's positive 9, I'm going to subtract 9. What else do I need to move? 2x. How do I move a plus 2x? I subtract 2x. Okay? So on the left, what is x minus 2x? 1x minus 2x. Negative 1x, right? 1x minus 2x is negative 1x. What's 9 minus 9? 0. It drops out. What remains on the right? 9 minus 9 cancels. 2x minus 2x cancels. I have 6 square root of 2x. Okay. With that in mind, is my radical term by itself? Yes and no. Are we saying it's not by itself because there's still a 6 out here? Okay. Which I agree to an extent, but here's the deal. I have the term, the square root term, all by itself. To get rid of the 6, I would have to divide it, which is going to create a fraction over here. I'll be honest, I don't really want to mess with fractions. So, as long as I don't have anything added or subtracted here, I'm going to consider this by itself enough that we can go ahead and square both sides. And I'll show you what happens here. Okay, so if there's a coefficient here, that's okay. We're going to make this work. So because it's a square root, we're squaring both sides. What is negative x squared?
X.
Positive x what? Squared. We're not squaring a square root on the left, right? So negative x times negative x is positive x squared, correct? On the right, we're going to square 6 square root of 2x. Now, 6 is not under a radical, is it? What is 6 squared? 36. Times, what is the square root of 2x squared? 2x. That's all multiplied. So what is 36 times 2x? 72x. So I end up with x squared equals 72x. Okay. Slightly different setup than what we've seen, isn't it? I don't know. Do you guys remember how to solve if there's an x squared and an x term? If it was an x squared and a number term, I would go for square rooting it. What was it? If you divide by x, you're dividing away an important answer. Okay? So, make this equation equal to 0 for me. So minus 72x. When you have an x squared and an x term, we're going to make it equal to 0. So I'm going to have x squared minus 72x equals 0, correct? How do you factor that? What do x squared and 72x have in common? An x. So they have a GCF of x. Yes? So we're going to factor out that GCF of x. If I factor out the GCF of x, x squared divided by x leaves me with x. Minus 72x divided by x leaves me with minus 72. Okay, guys, we're almost there. You have x times x minus 72. Two factors multiplying to equal 0. What do I do to solve? Set each factor equal to 0. So that means I'm going to set x equals 0 and x minus 72 equals 0. So I end up with x equals 0 and x equals 72. Now, I'm running out of time, more than I thought I would. And I'm going to tell you, you check these. You guys know you're going back into the original equation, right? You get one answer works, and the other answer does not work. Okay, so I'm going to go ahead and tell you that 0 works, 72 does not work. Okay, if you've checked, you'll figure that out. And of course, plugging into the original. Now, I'm running out of time. Okay, I really want to look at B. Although, I don't know, B's not a whole lot different than what we just did, is it? Okay. Let's at least start B. We'll see where we go with this. Or I can go down and do the word problem real quick and then come back and finish B. Or work on B. Let's do the word problem for a moment. Then we'll do what we can with B. Okay? Let's do that. Yes, I put a few problems in homework. Okay? Did I say that right? Yes, I put a few word problems in homework. Okay, so yes, you're going to have to read a few words. Now, number 1 step on a word problem.
Read it.
Read it. You don't get the right to skip the problem if you haven't even read it. You don't get the right to ask me for help if you haven't even read it. So read it. The formula, V equals square root of 2GH. Love when they give me formulas. Gives me the velocity V in feet per second of an object after it falls h feet accelerated by gravity g, if feet per second squared. If g is approximately 32 feet per second squared, what did it just say?
30.
G is approximately 32 feet per second squared. Find how far an object has fallen if its velocity is 72 feet per second. Now, I'll be honest, was there a bunch of stuff that was probably confusing there in the middle?
Yep.
Yes, that's fine. But can you pinpoint some pieces? I see a formula. Okay? It tells me G is approximately 32. So what am I going to use in this problem? We're going to use G as 32 in this problem. It told me that. It also told me velocity is 72. Look at your formula. What does that leave to find? V equals square root of 2GH. The only thing we don't know is H. Okay? You have a formula, you have numbers. Can you plug them in? Okay, let's plug them in. So if it's V equals square root of 2GH, V is 72 times the square root of 2 times G, which is 32, times H, which they didn't tell me. Okay, what's 2 times 32? 64. So then I have 72 equals the square root of 64H. What do you know? There's 2 different ways I could go with this, actually. Okay, and I'm realizing you guys are doing the opposite of what I did in my notes. The square root of 64 is 8, right? That would work. Okay, let's do that. So keep this as 72. The square root of 64 is 8. What about the H? Square root of H stays under the radical. I have 2 different options I could go here. What do you guys see?
Divide.
Could you divide by 8? I could divide by 8. If I divide by 8, I'm going to have 9 equals square root of H. Am I done? How do you get rid of a square root?
Square.
Raise it to the power of 2. What's 9 squared?
8.
81. What's the square root of h squared? H. Guess what? H is 81. Okay? That's solving an equation there. The other option right here, we could have squared both sides right here. That's what I did in my notes. I squared both sides right here, and then I solved. Would have worked the same, just different numbers along the way. Okay? And officially, this is 81 feet. Okay? I forget if I put 2 or 3 word problems in there, but give them a try. Don't just skip them. Yes?
32 feet per second squared. It's not squared.
That's just the label. Okay, that's part of a label. We talk about that more when we get into physics and calc and those type things, but we don't, yeah, that's part of the label, feet per second squared. Okay. Okay. Couple minutes left. We can look at B a little bit. We're not going to have a whole lot of time to do it, but you have radicals on opposite sides, yes?
Yes.
And what was the goal when there's more than one radical? Get them on opposite sides. I have them on opposite sides, so at this point, I can go ahead and square both sides. This first step is one of the important steps I wanted to show you on this one. That left, when I square it, what am I going to be doing here? It's going to be square root of x plus 1 times square root of x plus 1 plus 1. You're going to have to FOIL that. Now, don't let the looks of it get you. What is square root of x plus 1 times square root of x plus 1? What's the square root times itself?
X plus 1.
X plus 1. Square root of x plus 1 times 1. Well, that's going to be square root of x plus 1. 1 times square root of x plus 1. Square root of x plus 1. And 1 times 1 is 1. Clean it up. I have an x here. What's 1 plus 1? I have 2. Okay, guys. What do you think square root of x plus 1 plus square root of x plus 1 is going to be? 1 square root of x plus 1 plus 1 square root of x plus 1 is going to be 2 square root of x plus 1. Equals this right side that I never dealt with. The square root of x plus 3 squared. That's just your basic x plus 3. Okay? Similar to the last one, I still have a square root left, don't I? So I'm going to get that radical by itself. Subtract x, subtract 2. And I have 2 square root of x plus 1 equals to 1 there. And then just like last time, we still have a radical, don't we? If you still have a radical, square both sides again. Okay? On the left, when I square this, 2 squared is going to be 4. Square root of x plus 1 squared, x plus 1. And on the right, 1 squared is going to be 1. And now you have a very basic equation to solve. Distribute. 4x plus 4 equals 1. Subtract 4. 4x equals negative 3. You get x equals negative 3/4, and it does work. Okay? Get this homework done for tomorrow. If we are on e-learning, there will be most likely IXL. Okay?
What?